All right, so now we are going to actually see how we can run these Docker apps that you have downloaded or pulled. So we're going to actually try something simple, Linux images, Alpine, Ubuntu, Fedora, and BGBox and things like that. And then we are going to learn Helloworld applications that are posted by people. We'll talk about the concept of Docker containers in a bit more detail. And then we are going to actually run web application. Web application is something special in the sense that they need to expose their port, right? So we need to have what is called the port binding. Same thing with Nginx and Tomcat. So these are the servers, and they need to actually export their ports, right? Okay. Tomcat has some kind of manager application that is built in and is running on the top of port number 8080. So how you are going to actually expose that port to the external world, right? Things like that. We're not going to talk about the volume here, so I should actually remove this bullet. Okay, so let's try to run Alpine or Ubuntu. Those are popular images, Linux images. So we're going to actually do the lab. All right, so basically a few things I want to actually say is that in order to run an image, you're going to say docker run and the name of the image, and you can specify the command and argument for that image. Okay. You can also run it in interactive mode, and so in that case you say -i for interactive mode and -10 for creating a new terminal. Okay. All right. So we're gonna actually do these things, through the lab. So I'm actually rushing a little bit the slide. So let's actually do that here, step by step. Okay. So we are going to run ls-a. I mean, so Alpine is the Linux image, right? So if I say, let's just go over here. If I say docker run Alpine, it's not going to do anything, right? Oops, sorry, docker run. So run is the command that you are going to use to run that image, Alpine. By the way, if you have not pulled Alpine image, and it will try to see whether it has installed or not. If it has not been installed, it will actually install it first and then run it. Okay, so in our case, let's see whether we have Docker images. And we don't have any. So if I say docker run Alpine, okay, it's going to just run Alpine Linux image and then exit right away. Okay, and we're not going to see anything. Now it's actually, you can see it's pulling that image because we have not installed that image. So now if you say docker images, we should actually see that images as one of the images, the Alpine here. Okay. Now it says no command specified, so we're gonna actually use docker run Alpine ls dash maybe L or A, doesn't matter, right? Then you are going to see that executes that command. It will actually start the Alpine Linux image, and then it will execute this ls-a command, okay, using the shell. Okay, so that is that. We can certainly use the echo command. So yes, you can say docker run. I'm going to just use the Alpine and echo life is good, like that. Then it will actually execute that command, life is good. Same thing with you can use any Linux command. Okay. Now let's take a look at the running containers. In order to see the running containers, you are going to say docker ps. You are not going to actually see any running commands at this running the containers at this point, because what happens is that whenever you say docker run Alpine ls, it will start the Alpine, execute this command, and exit right away. So in order to see all containers, you are going to say docker ps and -a. Then it will give you all the containers and their status. So we have executed 2 Alpine commands here. So there are in fact 2 container instances but they actually exited status. Okay. All right. By the way, whenever you are running a container, Docker will actually give randomly generated names. So these are inspired bows and garland killed or something like that. It actually something that could be remembered, but it's just randomly assigned. Okay. But both of those are in fact in exit status, and we are not having any runtime running the container. Okay. All right. So let's actually see. So in order to actually you can actually start the container with the name of your own choice. So instead of actually using the names that are generated and assigned by the Docker system, you are assigning, in this case, my own Alpine. So I'm gonna say Docker run -- name my own Alpine, whatever name of your choice, and then you say Alpine, and I'm gonna say echo code with passion, like this. Okay. And then this is executed again. If I say Docker ps, there is no running containers, but if I say Docker ps-a, then it will give you all containers that have been created before. And here we have in fact the 3 containers, and they are all exited status. And here you can see the name of the container is in fact my own Alpine, because that's what I specified here. Okay. Okay. So all right. So that's what we did. And now we want to run Alpine Linux in interactive mode. So in that case, you can use -i for, actually I should say interactive rather than interface. And T is open the terminal window. So typically you can say -it or -i and -t, either one is fine. So instead of actually running in this case, Alpine, right away, the run it and then exit right away, we want to actually interact with that Linux image. So in that case, you're going to use -it. So I'm going to actually have this one, and so here before here I can say -it, right? Yeah, and I don't need to actually execute this guy. So I just want to actually interact with this guy, right? And then Docker run -it, see, unable to use system certificate, blah blah blah, response from daemon, no command specified. Okay, so Docker run -- name my own Alpine, and then -it. Yeah, okay. Oh, okay. So what's wrong with that? So oops, I want to try this. Docker run. Oh, I see. So I have to specify some command, right? So that's what I'm missing. Yeah. So here, Alpine. In this case, I want to actually run some kind of shell. Okay. So I'm gonna actually use the the shell here. Oops. What is, you have to remove? Oh, I already have using that name. So if I'm actually using this guy, right? Okay. So I have to actually give a different name. All right. So I'm gonna say my own Alpine 2. And then I got this the shell, so I can say ls and all the directories in top directory. I can go to temp and I can create some kind of file, hello.txt, and then I can type hello.txt. Okay, oops, not type here, cat hello.txt. All right, so you can say, yeah, so I'm basically interacting with this image. Okay, now I can actually open another terminal to see whether there are in fact any running the containers. So now I say Docker PS, and I expect this problem, right? Because I have not set up the environment variable, right? It doesn't know how to communicate with the default Docker machine. So again, I have to say Docker machine env to see all the environment variables that I need to set. So then I'm going to again capture this command and then execute it. Now I should be able to execute Docker PS default, well, without the default. So Docker PS, just PS, sorry. Yeah. So you can see now, I'm actually running this Alpine, my own Alpine 2 container is up and running. It's actually status is up about a minute because I have not actually exit this guy, right? So if I say exit, and then if I go over here, then we are not going to have any running container anymore. Yet if I say -a, then we should have this command is again exited status. Okay, and we have my own Alpine 2 and my own Alpine. So we have in fact 4 containers that are created using the same Alpine image. Okay, but they are all exited status. All right, so let's see what else you can do. Yeah, so that's basically what I just showed you. Now, if you want to remove all the containers that are not running status, okay, you can actually use what is called Docker container prune, right? So here, what I can say is that Docker. Let's actually take a look at the help. Docker the container the prune -- help. Yeah, so basically, remove or stop the containers. Okay, so let's do that. Docker the container prune. Okay, all right, and the confirmation. Now if I say Docker PS -a, there should be nothing. Okay. Okay, so for your own exercise, I want you to run BusyBox Linux image I should say interactive mode, and create a file in the temp directory, and then stop the container and prune the container and remove that image. Right now, if you say Docker image, there are no containers, but if I say Docker images, we should have the Alpine image, right? So if you want to remove this image, then you say Docker RMI Alpine, or you can say Docker image remove Alpine, something like that. Okay, so that is your exercise. I'll give you guys about 6 minutes to do this exercise. Now we're going to actually run some Helloworld applications. So in fact, there is official Helloworld image from Docker community. So you say Docker run Helloworld, and there is another one that we're going to actually execute. Okay. All right. So let's actually just run this too, even though it's all specified in the lab documentation. So I say Docker Docker run hello world, and again, if it is not been installed, it will actually install it first. So it actually gives you a sense of what happens behind the scenes. So what happens is that when you run this Docker run command, the Docker client will contact Docker daemon. Basically, Docker daemon is a process running a Docker machine. The Docker daemon pull the Hello World image from the Docker hub if it has not been installed previously. Then Docker daemon create a new container from that image, which runs the executable and produces the output you are currently reading. So it actually generates the output of this guy. And then Docker daemon stream that output to the Docker client, which is send it to your terminal. So that's basically what you're seeing here. Okay, so it's pretty good, description of what happens behind the scene. And it's pretty straightforward, right? Okay. There is actually another. So let's actually take a look. This one is yes. If you take a look at the lab documentation, let's actually do the lab here. So Yeah, so this is one, I just did unable to find image locally, so it's going to pull it from the Docker hub. And again, we just talked about this guy, right? Another one is what is called the Docker will say, and then these are the commands. Basically, you can specify the message. Okay, so first time you're executing this guy, again, it will download it and then execute it. Right, so it's pulling those images, and you can see it is made of multiple layers. And then it will display Docker kind of ASCII image. And yeah, so what you're gonna see is something like this. Okay, and the message is what gets displayed. So let's okay, here we go. If I want to give a different message, code with passion, like this, then it will display code passion and display. Once it has been downloaded and installed in your local machine, it doesn't have to pull it. So that's the reason it gets executed now right away. Passion 2. Okay, all right. So that is basically what happens. Now let's talk about the concept of Docker containers. We have done a little bit of the exchange of the Q&A on these containers. So these are the running instances of Docker images. Okay, so from a single instance, from a single image, you can actually have multiple instances of those. So again, the analogy is that Java objects instances are instances of a class, right? So you can think of image as a class, and the containers are basically Java object instances from that class. Okay. So there are a few commands that we can actually execute. So we are going to actually try this one in the lab exercise. So let's actually do exercise the 2.2. We just did it. And yeah, so the prune is to remove all the containers whose status is exited. Okay, so you can certainly remove those containers by using Docker container remove and name of the container, but that could be a little bit too you have, suppose if you have many non-running containers, then you have to execute that many times. So instead you can just say Docker container prune. So I think I demonstrate that. So let's actually see how many Docker let's see, Docker PS. These are running instances. We don't have any. And Docker PS-A, then we have probably a few the container instances that are in the exited status. So in that case, I can certainly create Docker container remove, and I can actually use the name or container ID to remove it individually like this. Okay, and then if I say the PSA, then you can see oh, well, it didn't actually Docker remove. Oh, no such container. That is interesting. Yeah, so I thought actually oh, I missed the Y at the end. Okay, so let's try it again. Yeah, Y. Okay. All right, so now it's removed. So if I say PSA, then we should have just the 3. So instead, I can say Docker, instead of actually removing it, removing container individually, I can say Docker container prune. Then it will remove all containers whose status are not running. Okay. All right, so say yes, and you can see 3 containers have been in fact removed. So if I say Docker PS-A, then we should not have any container instances. All right. Okay, so that is the lab here. So we did a prune, and then we see, yeah, so this is the running images. So prune is going to actually remove only the images that are not in running status. Okay. Okay, so for your own exercise, run Docker wholesale image processing for your own message and search for other Hello World images and try them out. Okay, yes, pretty straightforward. So let's actually move on to exercise 3. Now we can actually run Docker container in detached mode. Detached mode is actually different from interactive mode. Interactive mode is that you as a client can actually interact with that image. Detached mode is running that, running that image in the background. Okay, so you can actually use -- detach or -d, either option is fine. So here I'm actually running Ubuntu. I give a name to my detached Ubuntu, and I am running in detached mode. And here I'm actually executing this while loop. So here, while true, I want to execute echo command with the date. And then I'm going to sleep 10 seconds, and then I'm going to be done. So it's going to actually continuously display the date information in the background. Okay. All right, so let's just run this guy here. All right, so it's going to download it, and then when I say Docker PS, I should actually see this image. Okay, because I mean this container, because it should be running continuously in the background. Okay, there is a logs command. If you say docs logs and you provide the name of your container or the name of the ID. This is a case of ID. Okay, you can provide an ID or the name of the container. Then you'll actually see the log of that from the container instance. Okay, so that's what you're going to see. So now if I say Docker PS, we should actually see this is in fact the up and running, right? And so if I say Docker logs and I provide a name or an ID, then it should have this date message on and on. So if I run it again, it should have another one. Yeah, so 6, and because it's going to be running in this case indefinitely, right? Okay, so now you should be able to stop the container. So we are going to stop Docker. For now, this is the name of the instance. So if I want to stop this background running container, I say Docker stop, and you can again provide this container ID or the name. Okay, so I'm going to just use this name, and it should start. Okay, so it should stop. So if I say Docker PS, should not have any container instance up and running. But if I say PSA, we should have this Ubuntu the container instance in exited status. Okay. All right, so that is that. Again, you can remove the container using container remove on the name of the container, and then you should actually see that container should be removed. You can prune it, right? Sometimes you want to actually prune container, and then you want to prune the image. Now, if you try to prune, so let's actually try to if you try to remove this image, let's see what happened. So Docker the image remove, and image name is Ubuntu, right? And let's see what happens. It will say it cannot remove it because some container is using it. Okay, so container in this case E4, that is basically this guy, So when there is a container instance, whether that is exited or status or up status, if there is a container that uses that image, you cannot remove that image. So in order to remove your image, you have to stop and you have to actually remove all the containers that use that image. So if I actually remove the container, so I'm gonna say, yeah, so I can say docker container. I can use either remove or prune, okay, because that is in exit it status. If I say docker container prune, all right, now if I say docker image Ubuntu, then it should be able to remove Ubuntu image because no container is now referencing to that image. Okay, all right, so hopefully you got the sense of the relationship between container and its image. So this is the case that you can stop and remove all containers. Again, you can actually use this one in the PowerShell. So I can say docker PSA, and then I can stop all containers using, so basically if I say docker PSA and Q, basically it will give me all the IDs of the running container instances. Okay, so I'm going to stop them all and then I can remove them all. Okay. All right, so I'm going to give you guys about, let's say, about 10 minutes to do exercise up to this point. So far what we have run is very simple hello world like application, and now we certainly want to run some web application. So web application, as I said, has some set of ports that need to be exposed to the external world. So we need to do some port binding. So let's see how we can do that. So running static application, I am going to just moving forward. Okay, so yeah, a bunch of these things. So I'm gonna actually just use the lab documentation and I'm going to explain it. So first, we are going to run the web application image without the port binding, and that means we do not have a way to access that application. So that is in fact the static site, very simple, one single HTML page kind of application. So if you run it, we can certainly want to run it in the background because we want to have that application up and running. So we might as well just do, run like this, okay? So it's downloaded, it's up and running. However, we do not have a way of, so now we can tell it's up and running. So we can say, oh, it's still going on. We can certainly see that is up and running. And now if I actually, let's take a look at the what is called the Docker port. Docker port, if I actually see any port of angry, in this case the name of randomly assigned the name of this container, it doesn't have any port because we have not actually exposed any port. Okay, so we don't have a way to access this web application. So that's basically what this step 1.1 is. So this is basically you should not do these things without actually. You should always export some port. So I'm gonna just move on to 4.2. So there are two different ways that you can expose the ports of that application. One is using -P. The other one is using a dash small p. Okay, so as you're gonna see later on, yeah, so using -P, you're asking the container, or you're asking the actually Docker system to assign randomly generated host ports to the these ports of the container. So what has to happen is that in order to access container's port, you cannot access it directly. You have to use the host port, and those host port has to be mapped into container port. Okay. So by using -P, so by using -P, so here I'm actually running this application, this static site application using -P. What that means is that I'm asking the container to assign random host port, in this case 32769, to the port of container port of 80. So this container port 80 is the one that is actually being exposed by this static site application. Okay, so let's actually run this guy with -P. All right, now if I say Docker port static site. That's the name I actually specified. Okay, so here you have to specify the name of the container, not name of the image. Okay, so you can see this is the port mapping. So the container port 80 is going to be exposed as host port 32769. The container port 443 is going to be exposed as 32768 of host port. Okay, or you can say Docker PS, and it will also give this mapping. So this is again the host port, and this is the container port, and this is the host port, and this is the container port. So when you're using -P, you're asking the Docker system to assign a random host port to the exposed container port. All right, so let's see now. Now we want to access this application, right? Now, if you're using native Docker package, you should be able to say, HTTP and localhost : and the port that was actually assigned in this case is 32769, right? But if you're using Docker toolbox, so I'm gonna actually try to, if I try to local host, and it will not work because I'm actually using a virtual machine like this. It's not going to work. Okay, so instead what I have to do is I have to actually get the IP address of the Docker machine. So in order to get the IP address, you're going to say I want to actually go over here. You're going to say Docker machine IP, and this is the IP address I can use: 192.168.99 and 100. Okay, so now I can actually use, instead of localhost, I'm going to use this IP address. So basically what I'm doing is that this is the IP address of the Docker machine, and I'm actually using that Docker machine's port number 32769, and then it will be mapped to port 80 of the container. Okay, so if I run this guy, then you can see hello Sang. It's basically accessing that container web application. Okay. All right, so that is using capital P. All right, now I want to actually assign a particular host port number instead of asking Docker system, Docker machine to randomly generate the port number for me. So in that case, you can use -p. Okay, so the way you can do is that, so we're gonna actually stop the that container, and we can actually prune it if I want to, and then here I am going to assign 8090. This is the host port number I like to use rather than 332.7 whatever number. Okay, so you can certainly use p, and then you provide host port number, and this is the container port. Okay, and then when you say Docker PS, you can see this is the host port that is assigned, right? So let's actually try this. Okay, so what is the, I want to actually close these things. Okay, so this is the one that I'm using, right? Okay, so it's up and running. So we want to, let's actually we might as well actually use the different container name. So here I'm gonna say Docker runs. I'm gonna say static site 2, and author is still Sang, and detach mode, and here I'm going to use p, and now here I'm gonna use maybe 9000. Okay, this is the host port number I like to use, and it's going to be mapped into port 80 of the container, and the container is using 80 to expose the application, right? Now so it now created new container instance called the static site 2. So if I say ps2, we should actually see the container. Yeah, so this is one, static site 2, and you can see now is port 9000 is being mapped into port 80. Okay, so now I should be able to use, in this case, I'm gonna go over here, and I should be able to use 9,000. All right, and it got the same result, right? Because we're actually using the the other instance is still there, so this one still should work as well, right? Okay, all right. So that is basically what we are doing here. Okay, so we just did that. And so for your own exercise, I want you in fact download AXYKim00. That's actually my Docker Hub account. I actually pushed my very simple Spring Boot web application yesterday. So if you in fact Docker search AXYKim00 or something like that, you should actually see a single image that contains that username, and it's basically a web application. So I want you to download it, and I want you to expose it both --p and capital P and small p, and the container port in this case is 8080. Okay, so when you actually download it and run it with -capital P and small p, I mean, this is what you are supposed to see. Okay. All right, so I'm going to give you guys about 10 minutes to do exercise 4.